Hello everyone, this is Alexander Malkov with Energolikbez. Today we're going to talk about three-phase power. Europe, America, Asia, or even Africa. No matter where you are, in 99% of cases, you'll see that electricity is transmitted through 3 wires on high voltage power lines. Yes, exactly 3 wires. By watching this video to the end, you'll find out why electricity is transmitted around the world using 3 wires, why they're called phases and painted in different colors, and what those colors mean. Was Nikola Tesla involved in the creation of the three-phase system? Nikola Tesla? You'll get answers to these and many other questions if you watch the video to the end. Let's get started. First, we basically need to understand what a phase is and how alternating current is generated. We take a loop, place it in a magnetic field, and start rotating it. Due to the phenomenon of electromagnetic induction, an electromotive force begins to appear in the loop, and at its terminals. Voltage. If you connect a device or, for example, a light bulb to this loop, alternating current will flow through it. We can see it on an oscilloscope, just like on this graph. Hooray! We've seen how a simplified single-phase AC generator works. It produces a properly shaped sinusoidal voltage. Well, a person could just use one phase. What more could they possibly need? Just 2 wires. Transmit, distribute, transform, and use it. So why did we need more phases? The push for developing multi-phase systems came from the need to create a rotating magnetic field. Yes, you heard that right. A rotating field specifically. What is it needed for? It is needed so that alternating current, electrical energy, can later be converted into rotation. In other words, to use electric motors. Back in the 19th century, Nikola Tesla and Mikhail Osipovich Dolivo-Dobrovolsky were conducting their experiments to create multi-phase systems. So-called two-phase systems were tested, where 2 coils, positioned at 90 degrees to each other, were rotated in a magnetic field. Alternating voltage was also generated at their outputs. But if we look at an oscilloscope, we'll see that there is a 90-degree shift, or a quarter of a period, between the sine waves. This shift is what is called the phase. That's where the term phase comes from. A two-phase system. A phase is also what they call a generator terminal, or one of the wires in a 3-phase cable. Okay, 2 phases, we got them. Why was there a need for more? If we look at it, 2 phases already create a rotating magnetic field. How does that work? Let's take a generator, but in reverse. Let's take 2 stationary stator windings from a generator. We'll apply alternating voltage to them with a phase shift, and we'll see that if we apply voltages with a phase shift to these so-called stator windings, then when alternating current flows through them, a rotating magnetic field is created. So how does a motor work then? We place a magnet, the rotor, into this magnetic field, and it sort of latches onto the magnetic field with its opposite poles and starts rotating at the same speed as the field. And that's how we get a synchronous motor. This two-phase system was proposed by Nikola Tesla, and he patented it in 1888. This time I actually found this US patent in the Google patent system, and you can check it out via the link in the description. And right now I'll even show you a fragment of that very patent from that year. Well, it might seem like we could stop here. 2 phases should be enough, and that's it. But no. Experiments continued. In a 2-phase system, in order to transfer energy from the generator, the consumer requires either 4 or 3 wires in rare cases, since it is not possible to combine the ends of the windings into one common wire. In order for current not to flow through them, some equalizing current will always flow through the neutral wire in a 2-phase system, since a 90-degree phase shift does not result in the summation of voltage vectors. 0. Therefore, in 2-phase systems, transmission was carried out using 4 wires. It seems like there are only 2 phases, but 4 wires. And when Dobrovolsky was the first to come up with the idea to shift the windings in the generator by 120 degrees, he ended up with a 3-phase system. He worked on this development for a long time and eventually demonstrated it at the Frankfurt Electrotechnical Exhibition in 1891. A unique power transmission line for that time was created, stretching 170 kilometers. And at the beginning of this line there was a generator that produced a 3-phase voltage, then the 3-phase line itself, and at the end there was the consumer. The launch of this line is considered the beginning of the triumph of the 3-phase system, which spread throughout the world and remains predominant to this day. There are more 3-phase asynchronous electric motors in the world than any other type, and they are almost unchanged from the original design invented by Dolivo-Dobrovolsky. To be fair, it should be noted that although he is considered a great Russian inventor, in 1881 he was expelled from the Riga Polytechnic Institute, and he was banned from continuing his studies at any university in the Russian Empire for his revolutionary views and certain statements. He moved to Germany. There, he was readily accepted into the higher electrotechnical school in Darmstadt. He gradually became a faculty member, continued his scientific work, and got a job at the AEG company. As a result, he became not only a leading engineer there, but later also the director. He held that position until his death. He improved the design of the three-phase motor, generator, transformer, and essentially the entire three-phase system. So, what is the advantage of the three-phase system over others? 3 phases is the minimum number of phases required to create a stable rotating magnetic field, which can reliably start a motor and keep it running. The three-phase system is stable, balanced, and provides a high-quality rotating magnetic field. At the same time, it uses the minimum number of wires to transmit energy. Only 3? Because the 3 outputs of the generator winding can be connected at a single point. The sum of the voltages at this point will be 0. 3 vectors shifted by 120 degrees add up to 0. And in a 3-phase system, no current flows through the neutral wire. And if the load is symmetrical, we don't need the neutral wire at all. That's why all high-voltage power lines have only 3 wires. A low-voltage power line has 4 wires, but for other purposes, to be able to obtain both phase and line voltage. I'll make a separate video about phase and line voltage 22380 because the topic needs a more in-depth explanation. It turns out that the 3-phase system is not a universal discovery by accident. The number 3 is quite significant. You could say it's very balanced. A chair has 3 legs, the minimum number of legs needed for it to stand. A pyramid, the most stable structure, has a face in the shape of a triangle. And everyone knows that the most common tripod for photo and video equipment is a 3-legged one, that is, a tripod. But we don't even know what a monopod or bipod is. It's not stable, you have to hold it with your hand. Now let's talk about colors. When you pass by a substation, you might notice that the equipment for different phases is painted in different colors. And if you look closely, those colors are yellow, green, and red. Why exactly these colors? In electrical engineering, it's customary to designate the first, second, and third phases with the Latin letters A, B, and C. And the colors we mentioned, yellow, green, red, listen closely. The first letters of these words are Y, G, R. They go in order in the alphabet, one after another. Not directly one after another, but in order. Y, G, R, if you drop the vowels. So to avoid confusion, we'll know that Y, G, R corresponds to A, B, C. There, the letters are consecutive in the alphabet, and here the letters are also consecutive in the alphabet. So if a work order is issued for phase B, you can safely come and repair the green phase, because B corresponds to the green phase. That's a brief overview of the 3-phase system. If something is unclear or you want to know more, ask your questions in the comments. Subscribe to the channel and give it a like. It would make me very happy to see your likes, comments, and subscriptions. I was glad to share another Energy Basics lesson with you. See you next time. Bye.